All right, we're going to look at our review for the Unit 1 test here. And so we're going to start off with my questions should match along with yours. So hopefully you've tried and attempted them before you're watching this. So in our own words, we're going to define the following. Complementary angles. Complementary angles sum to 90 degrees. Okay, and these angles do not have to be touching in any way. They can be, and they most often are, but they can be separated. But as long as they add up to 90, then they're complementary angles. Supplementary angles sum to 180. So these are angles that when you add their degrees up will equal 180. Again, they do not have to be touching in any way. They could be totally separate. Vertical angles are congruent and are created by intersecting lines. So kind of a picture of that. So if I have this line, and it could be segments. So let's say I have this segment here. Okay. I've created a couple pairs. So there's a pair of vertical angles that are congruent. And here, above and below, those are vertical angles that are congruent. So you have two pairs of congruent angles there. Linear pairs are actually supplementary angles on the same line. Or they share opposite rays. So they sum to 180 degrees and are on the same line. Okay, and it's only two angles. Okay, supplementary angles. You could have like a group of three angles that are supplementary to each other if you wanted. We typically don't see that, but linear pairs is just two angles. Okay, so kind of a picture of that. They do form a line or a segment. They're on a straight angle, and then you could have something coming off here. So if this is 1 and this is 2, angle 1 and 2 are a linear pair. They add up to 180 and are on the same line. They are also considered supplementary, but we use the word linear pairs instead. Find the midpoint and distance of the segments with endpoints -3, 6 and -11, 2. So you can do this a couple ways. Number one, you could use the formula, or number two, you could graph it out and kind of use the Pythagorean theorem. So let's first look at the formula. So for midpoint, remember midpoint is just the average of the x's and the average of the y's. So we have -3 plus -11 over 2. And we have 6 plus 2 over 2. -3 plus -11 is -14, and -14 divided by 2 is -7. And 6 plus 2 is 8, and 8 divided by 2 is 4. So your midpoint is -7, 4. And that's the point that divides this segment into two congruent parts. For the distance formula, that is the square root of you're going to take and subtract your x's. Now, it doesn't matter which direction or which number you start with, as long as whatever you do with x, you do with y. So we can say -3 minus -11 squared plus 6 minus 2 squared. -3, this would end up being plus. So -3 plus 11 is 8. So you have the square root of 8 squared plus 6 minus 2 is 4. 4, so then you got 4 squared. So 8 squared is 64. 4 squared is 16, and you're going to take the square root of that. So you have the square root of 80, which is about, and then you can use a calculator for that. I encourage you to write that exact answer. But then we have about 8.94. Okay, so we can also look at this graphically, and we don't necessarily have to have an exact graph. If you want to, that's fine. So if I plot this point at -3, 6, we're going to go -3, +6. Okay, so -3, 6. And then we're going to go -11. So I kind of didn't draw my graph appropriate there. So we're at -11. So 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 1, 2. And I have this segment right here. Now, with that segment, we can create a right triangle to help us find the length. Okay, and we can count. How long is this? Well, 1, 2, 3, 4, 5, 6, 7, 8. How long is this? 1, 2, 3, 4. 4. And this created a right triangle. So for my distance, I can use the Pythagorean theorem that says 4 squared plus 8 squared equals c squared. And if you look right here, we did 8 squared. We did 4 squared. So we're already doing that in the formula. But if you want to do it this way, you can. Just remember in the end, so you're going to have 16 plus 64 equals c squared. That was 80 equals c squared. And then you're going to have to square root that. So you get the square root of 80 again. Now, for the midpoint, we can still use these values here, okay? And then we're going to just divide it by 2. Okay, so my midpoint's going to be halfway here. Let's see. Let's do this. It's going to be halfway here, and it's going to be halfway here. Okay, whatever this is. So half of 4 was 2. So you're already up 2, or you can come down 2 from here, which was 4, which matched with this number right here. And it's 4, half of 8 is 4, so you come 4 from this way, which is 7, which is right there. Okay, so you can use a graph to help you if you can't remember the formula. Draw 3 points, M, N, and P on a line so that ray PN and ray PM are opposite rays. So remember, opposite rays are rays on the same line that go in different directions. And here we can see that P is in both of them. And it's actually the starting point of both rays. So that tells me that P is between M and N. So there's N and here's P. We don't really know where P is or how far away, or maybe N is on the left, M is on the right. It doesn't matter. But here, right here is ray PN, and right here is ray PM, and those are opposite. So this would qualify as your picture there. Ray MO is the angle bisector. Remember, angle bisector, or a bisector splits something into 2 equal parts. If angle LMN, of angle LMN, find X and the measure of angle LMN. Okay, so here they note that they are congruent on each side. We're going to say that this is the measure of each one of those angles. So I can say that 4x minus 5 equals 23 because they were bisector. They were bisected. This right here bisected the big angle. And they tell me here that they're congruent. So here we're going to add 5. So 4x equals 28. And 28 divided by 4 is 7. So we divide both sides by 4. x equals 7. So x is 7. So we found x, and it says find the measure of angle LMN. So LMN is actually the big angle. Well, this angle was 23. If I plug 7 back in, I should get 23 for this one. So the measure of angle LMN is 23 plus 23, or 23 times 2, which is 46 degrees. Okay, because they are exactly the same. It's very similar to midpoint of a segment with angle bisector. All right, question 5. D, E, and F are collinear. E is between D and F. Okay, so that kind of helps us set up a diagram. So we have a line because it says collinear. D, E, and F are collinear, so they're all on this line. E is between D and F. So E, and let's say D and F. It says nothing about midpoint, so I like to offset that point between just a little bit. It says DE. DE is 2x minus 1. EF is 3x minus 3. And DF is 46. Draw and label a picture. We did that. Use the segment addition postulate to solve for x and determine the length of DE. Okay. So again, with that segment addition, we're going to take the little parts and add them together to get our larger segment. So our little part was 2x minus 1, plus the other little part was 3x minus 3, and that equals 46, our big part. So then we combine like terms. So I got 2x and 3x. That makes 5x. Negative 1 minus 3 is negative 4. 46. If I add 4, 5x equals 50. Divide both sides by 5, and x equals 10. Okay, so that was part of the answer, but then we got to make sure we go back because now it wants the length of DE. DE is 2x minus 1. I know that x is 10, so that's 2 times 10 minus 1. 2 times 10 is 20. Minus 1 is 19. So DE equals 19. Notice I didn't put a segment above this DE because I used the equal sign, and we're actually talking about the number or the measurement, not the actual shape. Okay, so here they provide us a picture. It says AB equals 7x minus 3. BC is 6x minus 1, and B is the midpoint. Okay, well, if B is the midpoint, I know that this segment and this segment are congruent. They are equal. Their values are equal. So 7x minus 3 equals 6x minus 1. Find AB, BC, and AC. So we're finding the measures of each one. So I got to find x. So we're going to subtract 6x. So you get x minus 3 equals minus 1. Add 3. And you get x equals 2. But again, that's not what it asked for. It wants AB. It wants BC. It wants AC. Now, AB and BC are going to be the same, but I need to take this 2 and plug it in. So I have 7 times 2 minus 3. 7 times 2 is 14. 14 minus 3 is 11. And you can actually write that over here if you want to show your work. So we get 11 here. If you want to show this work here, you can. 12 minus 1 is also 11, so you get 11, 11. And AC is 22. It's 2 times 11, or 11 plus 11. So these, these are your answers right here, okay? The important thing on this one was that it was a midpoint. All right, question 7. If angle COB equals 119, what are the measures of angle COA and angle AOD? Should probably have a little M right there. Okay, so they give us this diagram, so we're going to start labeling. So COB is 119 degrees. Okay, we have vertical angles in here. We also have linear pairs. Well, it wants to know COA. So COA, it wants to know this angle right here. And it wants to know AOD right here, this angle. Well, I know that the measure of angle AOD equals 119 because these two are vertical angles. Okay, those are vertical angles, and that's why it's 119. That is my work to show, knowing this definition. Now for COA, I know that COA and the 119 form this linear pair. Okay, so I know that the measure of angle COA plus 119 equals 180. So in order to solve for that measurement, I just have to subtract 119. So the measure of angle COA equals 61 degrees. So this is 61, this was 119, and this is 61 over here. And in fact, if I add them all up, I should get 360. I should get that full circle. Okay, these two will add up to 180, these add up to 180, these add up to 180. Each pair that are adjacent add up to 180. Draw an example of a linear pair. Okay, we kind of did this on the first page, but your linear pair has to connect, has to form a line. So we just draw a line, and then we can draw an angle or a ray off of that. We're gonna label some points here. Remember, a line has to have at least 2 points. So W, X, Y, Z. Okay, and I got that ray there. So my linear pair are angle WXZ and angle YXZ are linear pairs. Okay, so then you got your picture there to kind of help. And those linear pairs, those angles will add up to 180. That's that straight angle right there. Okay, some more segment addition. If BC is 23 and AC is 48, find AB. Okay, so we kind of labeled our diagram there. So we're going to take our little parts, which is X and 23, add those together, you will get the large portion. Okay, and then we just subtract 23. And X equals 25. Okay, units, whatever the measurement might be in. Two angles are complementary. The measure of one angle is 8 degrees less than the measure of the other angle. Find the measure of both angles. Okay, so we have these two angles. So let's say I got an angle here, and I have an angle here. Okay, and these two angles are complementary, means they add up. So if I take this angle plus this angle over here, I'm going to equal 90 degrees. Well, the problem tells me that one of the angles is 8 degrees less than the other. So let's say this angle is X, this one is X minus 8. It's 8 degrees less. So that kind of sets up our equation here as X minus 8 plus X equals 90. all in degrees. Okay, so we add like terms. So this is 2x minus 8 equals 90. We're going to add 8. 2x equals 98. We'll divide by 2. And x equals 49. Okay, which means that this angle right here is 49 degrees. And this angle over here is 49 minus 8, so 41 degrees. And if I add both of those together, I get 90 degrees. Don't forget to take your x and plug it back in. Okay, some angle addition. If angle MOC, okay, that's the big angle, is 48. So 48 equals something plus something else. Okay, and BOC is 21, so 21. Then what is the measure of angle AOB? So I want to know this other one. So we're going to put an X there. All I got to do, kind of like that segment addition, subtract 21, and X equals 27 degrees. Okay, so set up, if you want to label it over here on your picture as X, and then this was 21, and then you could draw maybe out here, this whole thing is 48. Feel free to label and draw on that picture. Okay, AOC, okay, that's the same one. AOC is 48, so this whole thing is 48 degrees. BOC is 2x plus 1, and BOA is 4x plus 5. Okay, so now we've got some larger expressions in here. So we're still going to add the two parts, so 4x plus 5 plus 2x plus 1, so there's our two parts, equals the whole thing of 48. Combine your like terms, so 4x and 2x is 6x. 5 plus 1 is 6, equals 48. We can subtract 6. 6x equals 42. And when you take 42 divided by 6, you get 7. Okay, if we check back to the question says, what is the measure of AOB? AOB. So the measure of angle AOB equals 4 times 7 plus 5. 4 times 7 is 28. 28 plus 5 is 33 degrees. Okay, so this angle right here is 33 degrees. I could find the other one. Okay, maybe it wants the other one too. COB. Well, that was 2 times 7 plus 1. Or you could take 48 minus 33. It doesn't matter. So this is 2 times 7 is 14. 14 plus 1 is 15 degrees there. Okay, so it may ask you multiple angles in that same question. Find the complement. Okay, complement was 90 degrees. Sum to 90. Find the supplement, which equals 180. Okay, sum to 180 when the angle is 33 degrees. Okay, so what it's saying here is it's saying 33 plus what angle equals 90. Then it says 33 plus what angle equals 180. Well, you're just going to take 90 minus 33 and get 57. So this angle is 57 degrees. And here you're going to take 180 minus 33. You could also, and you get 147 degrees. Also, if you already know the complement, to get the supplement, all you have to do is add 90 degrees. Okay, because a supplement is 90 degree more than the complement. Okay, so in this case, we just got to add that 90 degrees. Okay, here's kind of some fill in the blank type questions, or it gives you a diagram and it wants a few things here. So use the picture and name each of the following. A linear pair. I think this was maybe just a typo here. That 11. So name a linear pair in this diagram. Remember, a linear pair forms a straight line. Okay, so we're gonna say here's a straight line. This is one of our straight lines. You could use this line. Okay, so here's a line, and our two angles that form that line would be angle DBE and angle EBN. Okay, notice in the name how they share letters. That's how we know they touch. That's not the only one. You could have also said angle ABC and angle CBE. That's another one. Okay. Complementary angles. Those are angles that add up to 90 degrees. And the only one I know are these two angles right here. Because of this little square down here, I know that's 90. Well, these two angles add up to 90. So there's a few ways we can name those angles. We could say angle 2 and angle 3. And then we could use the three letters. So angle CBD and angle DBE. I don't want you to say angle B, okay? Because at the vertex of B, there are 1, 2, 3, 4, 5 different angles. So if you just say B, I have no idea what you're talking about. You can use the numbers, though, because each angle has a different number, or the three letters. C, vertical angles. Okay, with vertical angles, I have to look for intersecting lines. Okay, and here I have I have a line here and a line here. Okay, so if we look at some angles that are made there to be vertical, the quickest one that I see is angle 5 and angle 3. Okay, let me kind of draw on this. There's your line, and there's your line. Okay, 5 and 3 was here and here. You could state the other ones. You could say angle ABD. We got to say the whole angle. Don't go to C, go to D, the whole angle. And you could say angle NBE on that one as well. Okay, there's a couple different that you could say. A right angle. Okay, let me get this off here. A right angle is a 90-degree angle. There is one very clear one on here, and that is angle CBE. That is a right angle. Now, angle 1 is also 90 degrees because of this line right here. Okay, 90 plus 90 has to equal 180. Okay, so that I know is going to have to be 90. Okay, and the last one, adjacent congruent angles. Adjacent angles are touching each other. They share a side of their angle. Congruent means that they're the same. So if I look at this picture, I'm looking for two angles that share a side that are the same measure. Now, I don't know a lot of these measures, but I do know that this is 90 and this has to be 90. And those two angles touch each other. So that's angle ABC and angle CBE. And we could, if we wanted, we could probably go through this and get each angle, but that's the quickest one that we know right off the bat. Okay. Okay, they give us some notations on this one. It says angle ABD, so ABD is congruent to angle DBC. So these two are the same angles. It tells us that right there. So that tells me that 30 equals x plus 25. If I subtract 25, you get 5 equals x. And it didn't say it wanted the other angles. It just, I think the directions on your review say just find x. So we found x. And again, we know we can find this. This is 30 and this is 30. We can find the other angles as well. Okay, again, they tell me some angles that are equal to each other. WXZ and ZXY are congruent, which tells us that ray XZ is a bisector. And I can also say 60 equals 3x minus 12. So then we're going to add 12. 72 equals 3x. Divide by 3, and 72 divided by 3 is 24. Okay, again, this is 60 and this angle is 60. I don't have to plug that. I don't have to plug x in on these to find that out because it told me that they were congruent. Given that angle 1 is complement of angle 2, okay, that means they add up to 90. So I'm going to just take some notes here. So angle 1 plus angle 2 equals 90. Should be measure. Well, should be the measure of angle 1 plus the measure of angle 2 equals 90. If the measure of angle 2 is 17, okay, so 17 equals 90 plus, find the measure of angle 1. So we set up our equation based on this sentence right here. So all I got to do is minus 17. And the measure of angle 1 is going to be 73 degrees. And you can check yourself. Take 17, add it to 73, you should get 90. Okay, it makes life a lot easier if we set up this equation, especially once we move on to that next algebra class. Given that angle 3 and angle 4, or angle 3 is a supplement of angle 4, and angle 3 is 46, find angle 4. So again, the measure of angle 3 plus the measure of angle 4 equals 180. 3 is 46 plus the measure of angle 4 equals 180. So we're going to subtract 46. And you get the measure of angle 4 to be 134 degrees. So angle 3 and angle 4 are supplementary angles, or supplementary angles. Okay, so we got another diagram here. And again, sometimes on these you can have multiple answers. So give two other names for line AB. So here's line AB. One is line F, because that's that lowercase cursive letter there. You could also say, they said line AB, we could say line BA. You can switch the direction of those, or switch the order of those letters. Name 3 points that are collinear. Collinear means on the same line. So the only 3 points here on the same line are CAG. And again, the order of what you say those doesn't matter. C, name a pair of opposite rays. Okay, so we're going to be looking at that same line to get our opposite rays because you got to have 3 points. So we're going to say ray AG and ray AC. Remember, the first letter in your ray is the point that it starts. Okay, so this ray starts at A, goes through G. This one starts at A, goes through C. D, name a point not coplanar with points A, C, T. So a non-coplanar point. So A, C, T, that's this plane. They actually drew that plane. And the only point not on that plane is B. Okay, because G is on that plane right there with that line. Name a line contained in plane TAG. Contains mean on, inside or on the plane. So TAG, the line there, again, we've got quite a few names that we can do with that line. CG. Okay, you could say line CG, you could say line GC, you could say line AG or line AC. Okay, you can use any two letters on that line to name it. We most often use the furthest 2 points out, which is why I use C and G. Most often we use those two, but you could use A if you wanted. Name a plane that contains point B. Now, on the diagram, B is not in a plane. Okay. I could contain it in a plane, but right now it is not in a plane. So B is not in a plane. But if you wanted to create a plane with it, you just have to pick 3 letters. Okay. So we could say T, C, and B. I could draw a plane here that contains those 3 points. Or I could say CAB, okay, and that plane. And if I drew that plane, G would actually be in it as well. So I don't know what we could say, just CTB, plane CTB. But as it lies in this diagram, B is not in a plane. Okay, tell whether the angles are a linear pair, vertical angles, or neither. So angle 1 and 2. So here's angle 1. Here's angle 2. You notice they form this line right here. So they are going to be a linear pair. 2 and 5. 2 and 5. So I can kind of see this line, and you can draw on it, this line and this line. 2 is this entire angle, 5 is this entire angle, so those are vertical angles. And then 4 and 1, well, here's 4, here's 1. Those they're not on a line. This is a ray, so it doesn't extend, so these are neither. Those are neither because I can't form either one of those. Okay, it says ray BD bisects angle ABC in the picture. Find the value of X. Okay, this was pretty much the exact same one we did a second ago. So if BD bisects it, that means this angle and this angle are the exact same. So 30 equals X plus 25. And we subtract 25, and X equals 5. Double check to make sure you don't need to find the other angle. You don't. So X is 25, or X is 5, sorry. Okay, the measure of angle RST, which is the whole thing, is 134. Find the measure of QST, show your work. So we have 2 parts, so we're going to add our 2 parts together. So 3x minus 1 plus x minus 1 equals 134. So then we're going to combine like terms. So you got 3x plus x is 4x. Negative 1 minus 1 is minus 2. 134. Whoop. add 2, you get 4x equals 136. Divide by 4, and you get x to be 34. Now, I don't want x, I actually want the measure of angle QST. So QST, that is angle QST equals 34 minus 1, so 33 degrees. Okay, and on the test, there'll be some blanks on some of them. Go ahead and write that answer in that blank so that we can easily see what your answer is. Okay, and our last problem here, find the length of the segment with given endpoints A and B. Show your work round to the nearest tenth if necessary. Okay, so we want the length. We want the distance. So again, you can use the distance formula. Distance equals the square root of 3 minus negative 1 squared plus 2 minus negative 3 squared. So this is the square root of 3 minus negative 1. That's plus, so that's 4 squared. Plus this would be 5 squared. So 4 squared is 16 plus 25 and the square root of that. So 16 plus 25 is 41. And the square root of 41 is about, using your calculator there, round to the nearest tenth, it's about 6.4. So about 6.4. Okay. And the squiggly line, this squiggly equal sign means that you rounded or you approximated that answer. Okay, so that was the walkthrough through the whole review. Hopefully it helped. If you have questions, please ask, and good luck on your test.